All right, one more day talking about simple machines, and what we're talking about today is the inclined plane and a couple of different variations on an inclined plane. Again, in some books that you will see that inclined planes, wedges, and screws are treated as three different simple machines. Your book treats them as just variations on an inclined plane. And there's not really a right way or a wrong way, it's just the way that they chose to do it. So let's start by looking at an inclined plane. Normally we think of this as just a plain old ramp. And to find the mechanical advantage of a ramp, we're going to take the length of the slope and divide it by the height. Now, again, intuitively, you are already aware that the more steep the ramp is, the harder it is to get up. And so if you want to go up a ramp and you want a whole lot less force, you're going to have to make the ramp a whole lot less steep. I can remember when we would go into public buildings when my kids were real little, they always thought it was way more fun to go up a ramp than it was to go up the steps. And so they would go sometimes 3 or 4 times as far as my husband and I would go, because we decided we were taking the steps. It didn't take as long. And so they would go a whole lot further to go up that ramp just because they liked going up the ramp. But again, the longer your slope, you still get to the same height eventually, but you have to go a whole lot further, even though you're exerting less effort in order to get there. Okay, so length of the slope divided by the height. So let's say, as an example here, that my slope is 5 meters long, and let's say that the height of this is 1 meter. So the mechanical advantage of this particular ramp would be 5 meters divided by 1 meter, which would be a mechanical advantage of 5. So what that mechanical advantage means is that I can reduce the amount of force that I need to push something up the ramp by a factor of 5. I'll have a fifth of the force, but I've got to push it 5 times as far as if I just took it and lifted it up. Now, if you're trying to move a piano, obviously to pick the piano up 1 meter would be exceedingly difficult, so you would much rather push it a little bit further distance than you would to try and lift it up. And so the same type of thing is going to happen with people in wheelchairs, where it's not practical to try to pick them up a step. It's easier to exert less force and go a longer distance with it instead. Okay, so examples here, obviously ramps. Stairs are actually considered, from a physics perspective, they're considered a type of an inclined plane. It doesn't have to be completely smooth to be an inclined plane. If you think about it, it would still be much easier to go up a series of steps than to try to scale a vertical wall. So that's why you can still think of this as an inclined plane, because you're not going exactly vertically with it when you go up there. All right. So you can even think of a ladder as an inclined plane as well, because normally you are going to take a ladder and you're going to lean it up against something, and so you're going to use that to get up to the height that you're trying to get up to. Okay, now a wedge looks exactly like an inclined plane, but it's used differently. So you can see that I have 2 triangles here that, well, they were supposed to be identical, so we'll pretend that they are. So this particular one is an inclined plane, and I exert my force by going up that ramp, by going up this direction. On a wedge, though, when I exert force, I'm exerting it from this direction, and I'm driving it down this way. The whole purpose of an inclined plane is to reduce force, but the purpose of a wedge is actually to magnify the force that you're going to use when you're doing this. So an example of this, of a wedge, is a knife or an axe. If you've ever, I can say a wedge, I don't know if all of you know what that is. I have a son who likes to sell firewood for a living, and so a lot of times he'll have to take a bigger log and he'll have to cut it into smaller pieces so that it will fit into people's wood-burning furnaces or fireplaces. And so a lot of times he will just take a big we'll call it an axe. He calls it something else, but he'll take an axe and he'll split the firewood into smaller pieces. Sometimes though, you have to use, depending on what type of wood it is, sometimes you have to use a wedge and then drive that wedge down in there to actually get the wood to split. So when you do that, you're going to drive it from this end, and then this is going to take that log and it's going to split it apart. Okay, so again, with a wedge, your effort's coming from this direction, where when you're using a plane, you're actually taking the effort and you're sliding it up just one side. So if you're going to calculate the mechanical advantage of either one, you do it using the exact same formula. You're still going to take, even if it's a wedge, you're still going to take the length of the slope and you're going to divide it by the height. This is the same way that a knife works. If you're using a big butcher knife to cut something up, you know, your handle is down along here, and this is the sharp point of the knife, and so you're exerting the force here in order to exert it on whatever food you're trying to cut. Okay, so inclined planes, wedges. Sometimes we'll actually use a double wedge. We'll use another wedge kind of on this side to make it even. To make it a more efficient machine for us to use. And then finally, a screw. Now a screw is actually an inclined plane that's wrapped around the axle of a wheel and axle. So I'll try to show you that. Here I have just a piece of paper in a triangular shape that it's supposed to look like an inclined plane. You can see that I have the slope of that colored red. And so if I take this and I take this inclined plane and I wrap it around the shaft of this pencil, you can see what happens here is that if you look at now where the red line is, it looks like, oh, I would have a screw. And so I've taken that inclined plane and I've wrapped it around this axle. Okay, so that really is what a screw is. The pitch of a screw is the distance between the threads on the screw. And again, it is possible to calculate the mechanical advantage of a screw. You have to have the pitch and you have to have the circumference. We're not going to worry about it in this class, but be aware that it is possible to calculate that mechanical advantage. One thing that I want you to be aware of though, because it's very much related to an inclined plane, if the pitch is small, okay, in other words, if the threads are really, really close together on your screw is going to be much easier to turn. And the reason is because that's going to be like a really long, not very steep slope. Okay. On the other hand, if your pitch is large, there's a lot of distance between the threads. That's like having a very, very steep slope, and so then it will take you less turns, but it's going to take you a whole lot more force to get that screw inserted into your wood. Okay, so variations on an inclined plane, a wedge, and a screw, and then that will finish up our study of simple machines.